In the following slides, we will demonstrate how Dijkstra algorithm works for the graph shown in the slide. Now, we will start from the node A. We consider the distance of this node A is 0. And then all the nodes of A, that is all the adjacent nodes of A, are taken into account. That is, the nodes which are not yet visited or rather I say they are not yet finalized. They will be taken. And their distances from A are updated. Remember, here we consider 3 states for the nodes of the graph: unprocessed state, ready state, and processed state. Initially, all the nodes will be assumed to be in unprocessed state, and when they are identified to be adjacent to one of the ready state nodes, they are considered to be in the ready state. Once we identify that they are along the shortest route, we consider or we make them final state. 3 colors are used to show these 3 states of the nodes. Now, the blue color for the node A indicates that it is in the ready state. Now, for this node, we consider all the adjacent nodes and we make them also ready. And also their distances from A will be updated. That is, minimum distances from A are updated. While doing so, the weights, the arc weights or edge weights are taken into account. Node B distance as updated as 5. Node C distance is updated as 5. Node D distance is also updated as 5, as the edge weight of E3 edge is 5. That is, D can be directly reached via this edge. Its weight is 5. Thus, as of now, the minimum distance from A to D is 5. For node E, distance is also updated as 5, as E4 edge weight is 5. Node F weight will be adjusted as 1. Out of all the nodes which are in the ready state, that is B, C, D, E, F, F is the one which is having the shortest distance from A. That will be made as a finalized node. Now, we will update the adjacents of F, adjacent nodes of F, which are not in the finalized state. They are B and E. Their distances are updated. If we verify, to reach E directly from A, it takes 5. However, if we go via F, it will be 1 plus 2, 3 only. Similarly, for B also we can verify. Accordingly, the weights of the vertices which are adjacent to F will be updated. The minimum distance with E is updated as 3. The minimum distance of the node B is also updated as 3. Now, if we verify all the nodes which are in the ready state, that is B, C, D, E, and their distances, the smallest is 3. However, both B and E are having smallest distance 3. We can select any one of them. However, we have taken the node E, so that will be finalized. That we assume that is in the minimum distance or minimum distance route. We have to update the weights of the vertices which are adjacent to the node E now. The adjacent, that is unprocessed, rather I say are ready state nodes. For E, the adjacents are D. However, D is already having a minimum distance of 5 from A through the edge E3. However, even if we go via E, it's also 5. Thus, we don't want to update the minimum distance of the node D. Now, if we verify for the node which is having the smallest minimum distances out of the nodes which are in the ready state, that is out of B, C, D, B is the one which is having smallest distance, that is 3. So that will be made as finalized node. Now B's neighbors which are in the ready state, that is C, if we observe, C is having direct distance of 5 via the edge E2 from A. However, if we go via B, the distance to C from A is 3 plus 1, 4. Thus, the distance of C is updated as 4. However, if we verify, B doesn't have any more edges. If it contains any more vertices which are unprocessed or in ready state, their weights also has to be adjusted. Now we will be selecting C as a vertex which is having the shortest distance from A out of the nodes which are in the ready state. That is out of C and D, C is the shortest distance. Thus, we'll make it as finalized. Then we'll try to see whether its adjacent vertices can be updated or not. Finally, the node D is also considered as finalized. Like this, Dijkstra's algorithm will give the minimum distance from a node to all other nodes of a graph. The path is, minimum distance path is A, F, E. E, F, B, C and AD. Those are the edges which are highlighted. They are the ones which are in the minimum distance path. Let us have one more example solved using Dijkstra's algorithm. Consider the graph as shown above. We wanted to find out the minimum distance path from A to all other nodes. So we start from A and consider A state as finalized state. All its adjacent vertices, their minimum distance has to be updated now. Distance of E from A is taken as 6. Distance of C, the vertex C from A is taken as 3. Distance of D, the vertex D from A is taken as 1. Distance of B, the minimum distance of B from A is taken as 1. The nodes B, E, C, D are the ones which are in the ready state. That is, they are not in the unprocessed state. They are in the ready state. Means they are being visited now, but not yet finalized. If we verify the distances of them from A are 1, C is 3, E is 6, D is 1. Both B and D are of distance 1, so we can select any one of them in the next step. We will be selecting D in the next step. Now the vertex D is finalized, that is, its state is made as final. That is, the edge A to D is considered to be in the final minimum distance route. And now we are supposed to verify all the vertices which are adjacent to D and are not in the finalized state. Their distances, that is minimum distances from A, has to be updated. The minimum distance of F is made as 2. Now out of all the nodes which are in the ready state, that is B, C, E, F, B is the one having smallest distance. Thus, its state will be made as 5, and then its adjacent vertices distances are updated. That is, G distance is made as 2. Now again we have to find out the vertex out of the vertices which are in the ready state, which is having smallest distance. That is, out of the nodes G, C, E, F, F is the one having smallest distance 2. Of course, G is also having smallest distance 2 from A, but however, we have taken F now. Thus, its state will be made as finalized. We are required to update its adjacent vertices distances. Now, out of the remaining nodes which are in the ready state, that is G, C, E, G is the one having smallest distance, that is 2. Thus, G will be made as finalized, and its adjacent vertices are updated. That is, their distance will be updated. Thus, H distance becomes 3.0, that is 3. Of course, its state is also made as ready state. Now again we have to find out the node out of the ready state nodes which is having smallest distance. Now if we verify C is the one having smallest distance, thus its state will be made as finalized. And then its adjacent nodes are supposed to be updated. Thus E becomes having distance 5. That is, directly from A to E the distance is 6. However, if you come via C, the distance of E becomes 5. Then out of the nodes which are in the ready state, that is H and E, H will be made finalized as it is having the smallest distance. Also, the distance of E is updated. The distance of E via C is 5. However, if we come via H, that is A, G and H, D, the distance will be 4. Thus, E distance is updated as 4. Out of the nodes which are in the ready state, incidentally here there is only one node which is in the ready state, that is E. It will be made as finalized. If we verify the graph, the arrows, the edges which are highlighted, they are the smallest routes or the minimum distance routes from A to all other nodes in the graph. Like this, the Dijkstra's algorithm works.